Assalamualaikum and good day everyone. In this video, we are going to learn on what to do when a function becomes longer or more complicated. So basically, the idea is when you have a different structure, you will use a different techniques, right? Just like in simple mathematical function, right? We have a basic mathematical operation, which is plus, minus, multiply and divide. So basically we're going to see if we have those kind of operation that needs to be conducted in differentiation, how to do it. The first technique, as you can see here, is how to find a derivative of sum and difference rule. It literally means that if a function is added or subtracted, what do we do? So basically we have a counter with this kind of function before several times. So basically what we did is we differentiate each term separately. Alright, let's do the example. The first question consists of sums of 4 terms, which are the first terms that consist of the terms that use power rule, the second terms that will use exponential rule, the third terms that use triangle rule, and the last term that use natural log rule. So let's differentiate one by one. For this one, we are going to get 2 times with 4x to the power of 3. So combine it, you get 8x 3. For this one, the form retained, which is exponential x, and for this one we get 2 over 3 times with cos kx, so we get negative 2 sine 2x, which will give us negative 4 over 3 sine 2x. And for this last term, you should get 1 over x. So this, all of the 4 term has already been differentiated. So the next thing to do is to again combine everything. So the answer is 8x to the power of 3 plus with exponential x minus with 4 over 3 sine 2x plus with 1 over x, and this is its dy, sorry, it doesn't have y, right? D over dx. And let's look at the second question. Now for the second question, let's answer several things before we proceed with the differentiation. First, should we first differentiate this constant into this bracket, right? Differentiating all the terms with 1 over 3. Should or should we not? So let's try to answer it through demonstration. So let's say we multiply it in first, right? Let's say we try to start with the first function, x to the power of 7. So times with 1 over 3, you will get 1 over 3 x 7, right? But to differentiate it, right, our usual practice is to split the constant. So basically later on before we conduct the derivative, we will pull it out, right? So dy over dx x 7. So basically what I'm trying to tell you here, don't multiply in the constant when you see this kind of question, because later on you will pull it out again. So it is actually quite meaningless. So instead of start with multiplying the constant in, we can just ignore the constant and just differentiate everything inside the bracket and multiply with the constant at the end. So let us first split the terms, and then we'll discuss what is the second point that should we notice before we proceed with the differentiation. Now let's look at the terms one by one. So for the first term, it is just a power rule, one terms of power rules, and then this is just another terms of also power rule. Let's look at these last two. As you can see, this one is sine x squared. First, let's be clear that this sine x squared is not the same with sine squared x. Okay, back then, right, in our discussion, when we encounter with sine squared x, we always change it into sine x squared. So basically, these two are not the same. So basically, for this sine x squared, it is actually involved two terms of sine, and one more is x squared. Or we can also write down like this. It is actually, this is where the bracket should be. Right? Or let me just repair the bracket, right? Yeah, like this. So how do we differentiate this? The same goes for the second one, exponent to the power of x squared. You have x squared as its power. So basically we have actually two functions here. So you have exponent to the power of x squared. The x squared as another function. So usually for this case, we going to use chain rule, which we are still not covered. We are going to cover it after this. So because of we haven't covered chain rule, we can still solve it using the way that we discussed up until now, this branch kind of solution. So let's but the only thing that you need to do is, because of we have function inside of function, right, like what we did before, we need to create another branch out of this single function. So the first one will be sine of whatever function inside. We are going on to the first one. We are going to just focus on the what we call outer function, and the second one we are going to write the inner function, which is the x squared. The same goes for the exponent function. We are going to split it into two branches. The first one will be the differentiate exponent to the power of whatever inside the bracket. So we are just going to focus on the exponent, and then the second one will be the exponent of the inner function, which is x squared. So let's differentiate one by one. So for the first function, using the power rule, we will get 7x to the power of 6. And for the second function, second terms, we get 9. And for this third terms, we have cos, right? Cos of whatever inside the bracket. And for this one, we get 2x. Okay, so is it solved? No, it is still not, because it is actually come from one function, inner and outer. We need to combine it back, multiply it together. So let's multiply these two, right, before we proceed with combining with others. So basically it is cos, let's put it back whatever in the brackets. So x squared, cos x squared times with 2x, which will give us 2x cos x squared. Okay, and then let's do the same for the exponent function. So differentiate this. Again, for exponential, it is actually quite simple, where the function retain, the terms retain. Okay, and for this one, we get 2x. So because of they are from the same terms, inner and outer, we are going to multiply it together. So it is actually exponent of, let's put whatever inside the bracket, which is x squared, times with 2x. So which will give us 2x exponent x squared. Okay, so now that we have differentiated everything, we can just combine them together. So we pull down everything. So we start with 7x to the power of 6 plus 9 plus 2x cos x squared plus 2x times the exponent x squared. So this is its dy dx, isn't it? No, it's not. Because why? Remember, we actually ignore the first constant, which is 1/3. So let's put it back. So this is the final derivative should be 7/3x to the power of 6 plus 9/3 is 3, and then plus 2x cos x squared over 3 plus 2x exponent x squared over 3. So this is actually the final form of its derivative. Now let's look at the next question, which is on the exercise. So for this case, we have 1, 2, 3, 4 terms, which consists of addition and subtraction. So let's define the terms. Let's split them first. So unlike our previous example, this question is quite straightforward. Right, we just need to change some form. So the first one, we have negative 2 times x negative 8. So we pull out this constant, and this is how it looks. And then for this one, right, this is actually 2 times with the square root of x. So 2 is the constant, we pull it out. That leaves us with the square root of x, so we change it into a form of this. The next one is actually negative sine 3x, and the last one is 1 over 3 times tan 2x, so we pull out the 1 over 3, leaving the tan 2x as its terms to be differentiated. So let's differentiate it right away. So for this one, we have negative 2 times with negative 8 x to the power of negative 9. And then for this one, we have 2 times with 1 over 2 x minus 1 over to the power of negative 1 over 2. Okay, and then for this one, we have sine 3x become cos, so 3 cos 3x, so the negative retain, so negative 3 cos 3x, right? Sine becoming cos, right? And then for this one, 1 over 3 tan 2x becoming 2 secant squared 2x, right? So it is actually 2 secant squared 2x. So I forgot to actually solve this right away. So for this one, it's actually becoming 16x negative 9. And for this one, 2 over 2, so 1, so that just leaves us with x negative 1 over 2. As for this one, actually done. And for the last one here is actually 2 over 3 secant squared 2x. Okay, so that's it for this one. We can combine them. Okay, so we have 16x negative 9, right? Or we can also write it in reciprocal, which is 16 over x to the power of 9, right? And then plus with x to the power of negative 1 over 2. So there are two things that we can do here. For the first one, 1 over 2 here can become the square root back, and then negative can become the denominator of a reciprocal. So we going to have 1 over square root of x. And then the next one is negative 3 cos 3x, just read straight away. And the last one plus with 2 over 3 secant square 2x. Okay, this is its dy dx. But bear in mind that changing it into this form and this form is actually not really necessary. You can just leave it in this term, so it's still acceptable. So let's look at the next question. For this one, again, 4 terms of mix between addition and subtraction, and all the 4 terms look quite direct and not complicated. So the first one actually can be solved by using power rule. The second one, alright, again power rule. Some of us not actually realize it, right? This actually a constant, right, that being multiplied with 1 over x squared. So you can pull it out, right? Pull the 5 out, leaving 1 over x squared that will later be changed into a power function. The second function is this, right? Some of us might not realize it, but it's actually 5 times with 1 over x squared, where later on x squared can be changed into power form, becoming x negative 2. And the next 2 is actually already in its form, so we can just proceed with the derivative. So for this one, we get 1 over 4 x to the power of 1 over 4 minus 1, so you will get negative 3 over 4. Right, and for this one, first we can change it into power form, so it becomes x negative 2. Then we differentiate it, so we get 5 times negative 2x to the power of negative 3. And as for this one, right, nothing changed. We're just going to do its derivative. The same goes for this one, right? Because of it is, we have negative 5 as the k, we are going to use the exponent to the power of kx. So times with k, so we have negative 5 times with negative exponent negative 5x, which will give us 5 exponent negative 5x. So for this one, it's actually negative 10 x to the power of negative 3. Okay, I think we have solved everything, so we can put them in together. So the first one, we have 1 over 4 x, or I can just write down x over 4 to the power of negative 3 over 4. Okay, and then minus with 10x to the power of negative 3. Then minus with 1 over x. And then plus with 5 exponent negative 5x. So this should be its derivative. Let's look at the next question. Oh, sorry, it is actually the last question for the add and sum rule. So the next part will be chain rule. We'll see you in the next video. Thank you.